Okay, let's do practice quiz 10, number 3. So let's look at an example first. So suppose that 95% of the time a professor is no more than 5 minutes late or early to their class that starts at 5 p.m. You could then say with 95% confidence that the professor will arrive to class between 4:55 p.m. and 5:05 p.m. We call the time interval from 4:55 to 5:05 our confidence interval. So we can say with 95% confidence that the professor will show up to class between 4:55 and 5:05. Moreover, we call the 5-minute spread. So you're going basically 5 minutes from 5 o'clock back and 5 minutes forward from 5 o'clock. We call that the margin of error. Okay, so if n is larger than or equal to 30, then we can use the central limit theorem to show that, in general, this is how you'd find the confidence interval, a 1 minus alpha confidence interval for a population mean mu, where z alpha over 2 is defined down here. We'll talk about that in a second. Moreover, we call this sigma over square root of n, z alpha over 2, the margin of error. Okay, so let's look at an example. So suppose we measure the heights of 36 randomly chosen men and get a mean height of 70 inches. If the population standard deviation is 6 inches, then find the 95% confidence interval for the population mean. Okay, so let's do this here. So in our case, we have 0.95, that's our confidence level. That's going to equal then, so over here, the 1 minus alpha is the confidence level. So I'm going to set, that's why I set 0.95 equal to 1 minus alpha. So we have this. Solving for alpha then, well, how you'd solve this, you could subtract 1 on both sides, but just looking at it, think of the one like $1. So $1 subtract how much makes 95 cents. Well, you have to subtract 5 cents from $1 to make 95 cents. So that means the alpha has to be 5 cents, which is 0.05. We get then alpha, or alpha equals 0.05. Also, in our case here, it says 36 randomly chosen men, so n is 36, because it's 36 randomly chosen men. We have our height of 70 inches, that's going to be our x bar. So we're going to write x bar equals 70 inches. So x bar is 70 inches. And our sigma, so our sigma here is, it says 6 inches, so sigma is going to be 6. Okay, so let's keep going then. So let's look at our formula for the confidence interval up here. So it's right here. So now you're going to use this. So now use that. So now use this guy. So we have to find our z alpha over 2. So now note alpha equals 0.005 implies that we need to find, so up in this formula here we need to find alpha over 2. So implies then alpha over 2. So alpha over 2. Alpha over 2, right here. So alpha over 2 then equals 0.05 over 2. And that'll become then 0.025 if you divide it there. 0.025. Okay, need to find now So it's basically this guy here with alpha over 2 being 0.025. So let me write that. Okay, so writing that, whatever, p z less than, so it'd be z alpha over 2, so it'd be z, or alpha over 2 value is 0.025, so it'd be 0.025. And then this guy will be equal to 1 minus 0.025, 0.025. And if you do that subtraction, you get 0.975. Okay, so now we have to use our z-table. So using our z-table, we're going to look in the body of the table for a value of 0.975. Okay, so let's do that. Okay, so again, we're going to be looking for 0.975 in the body of our z-table. Okay, so 0.975. So click on our z-table now. Enlarge it. So I'm looking for now 0.975 in the table. So looking here, you may not be able to find it exactly, but you'll find the one closest to it. But actually, I do see it actually right here. So let me go like this. So 0.975 right there. Then what you do is you find a z that it came from. So it came from 1.9 that way, and going up this way, 0.06. So it's like 1.96 will be our number. Okay, so let's put that into our document. So close the drawing here. 1.96. Okay. So it'll be then, we can see here. So it's 1.96. So we can say then, hence z of 0.025 is 1.96. So this guy. Okay, so we're going to plug now into our formula here. So plugging into our formula, we get, so basically I'm going to plug it into this guy here. So, oops, it's this part right here. Yep. In our case then, well, the x bar is 70, so it's going to be 70 plus, so our, let's do here, insert, so our sigma was 6, so 6 is going to go on top, divided by square root of n, so on the bottom is square root of n. Our n value here was 36, and this is going to be multiplied by our z alpha over 2, which is this guy here, which is a 1.96, so multiplied here by 1.96. So this will be then equal 70 plus, it's going to be 6 then. The square root of 36, this guy here, square root of 36 is 6, so it'll be divided by 6 times 1.96. So working this out, you can check it's 71.96. Well, I guess we can write like this to be 70 plus 1.96. That'll be just 71.96. Oops. Yep. Okay. next. So in a similar way, we'll have this guy equals, so you're making the substitutions here, it's basically going to be just 70 minus 1.96. So it's going to end up being 68.04. 68.04. Okay, so we found our interval now because we found this guy here was the 68.04, and we found this part over here was the 71.96. So hence we can say with 95% confidence that the population mean is in the interval. So okay, on the left side it was the 68.04 guy here. It was 68.04 comma to 71.96. Moreover, our margin of error should we say here, margin of error so margin of error is, so if you go up to that's the definition of margin of error right there. So I'll take that, paste it here. And we've already computed that actually over here. It's right there. So equals this guy. And we already shown square root of 36 is 6, and it just becomes 1.96. So our margin of error is 1.96. So we can say with 95% confidence that the population mean is in the interval 68.04 to 71.96. Okay, so we're done.